Good morning, everyone.
Good morning.
Morning.
How y'all doing today?
Better now that I got coffee.
Outside.
Oh yeah.
Yesterday was too. So, how was your test yesterday?
Everything was going great until one part, and it was just like, oh crap, wasn't it?
What part?
I think it was the part where I kept getting a native VLAN mismatch, and then
I see.
yeah, so I finally fixed it, and then at the end when I tried to ping across from like VLAN 5 to VLAN 6, it wouldn't let me ping, but I can VLAN ping all the like 5 can ping 5. The servers are updated, the switches, no problem. I don't know.
We'll see. Anyway, so today we need to finish chapter, hopefully we can chapter 4. Most of this information, basically, I assume you cover part of it on on Windows 10, but some of it is new to you for Windows 2016 because it's a different technology. Okay, any question about what we covered last time? Let's see who's on the list. Okay, we got everybody on the list. Not everybody, a few. We still have a few people sleeping. Anyway, so today we're going to talk about the small computer system interface. That's what's been known as a SCSI drive. SCSI drive has been in the market for a long, long time, and it's very, very. It used to be, still some server use it. The SCSI, it's fast, and you can connect multiple devices to it. I think it's up to 16 or 15 devices in one cable. Okay, they daisy chain them in one cable. So, and also we have we have a lot of different types of SCSI. And you've seen like some of the hard drives, like the big ones. Okay, we use them for a server, and you didn't need a cable in there, so they have some kind of interface. If you remember that old parallel cable printer, you just take that drive and push it on that slot and make that connection. It's like it's like a back plane connection. So, and the good things about those type of drives, it used to be like it's faster than regular discs, and it has like almost not almost, it has 15 RPM, 15,000 RPM, which is super fast for comparing to the parallel and the regular SATA. Okay. Still, some people still using them. I'm using them. I got a friend of mine has a server, so I help him out sometimes. And so I have to order some drives for him. And usually it's very, very, very expensive, those drives. Even it's not too much in volume or capacity, like a 300 gig SCSI, I will say it used to cost about $300-400. Okay. And it's because of the type. Anyway, So what they're talking about in the book, they say latest variation is Ultra 640, which supports up to 640 megabytes per second transfer rate. Now, the big SCSI drive is replaced by what we call the serial attached SCSI, which is smaller and faster drive. And the transfer rate is 6 gigabit per second and higher. Now, I don't know. They made a mistake here. 640 megabytes, 606 gig. Yeah, 6 gig is pretty good in transfer rate. The SATA drive can be connected to the SAS backplane. It's basically you push it in. It's like the old SCSI, but it's different interface. It's the same concept though. Okay, but it's a different interface. And that's what we had. I told you about the those two servers we have on the lab. They use the serial attached SCSI, the SAS. We use it. It's the same size as a little small SSD drive, but it has has a little interface. Okay, especially designed for servers. And we have on one server we have maybe about I think we have about 15 drives or so. 15 drives, I think we have. So now some people are still using them. I have a couple of them. I bought a couple of them for me, for my server over here. So those are popular ones. Okay, the next one we talk about, once you get all the disks, whatever types of disks you decide you want to put in there, then you need to prepare them. So once you format them, you create some kind of volume. So on the old days, we used to call it partition. Now they call it volume. So I don't know why they changed it. So can use you can put the drive in one volume if you want to, or you can do what? A multiple volume. And sometimes we have, you divide your, if you have a multiple disks, you can create what we call a spanned volume, like you get space from different drives and you can make one volume if you want. But anyway, so Microsoft, whenever you install the operating system, you can have something called a boot volume. So the boot volume basically is typically is drive C, okay? So this is where you install the Windows folder. You remember that if you go to directory, CD, Windows, you can see Windows is on C drive. You see that directory in there. Now, can I put the folder, the boot partition on a different partition or different volume? The answer is yes, you can. But typically C, okay? So, C, that's what you get. So we have the Windows folder, which contains all the files, and this is what we call boot partition or boot volume. In the old days, we used to call it boot partition. Now they call it the boot volume, which is the same thing. And we have something we call the system volume. System volume or system partition. Basically, Windows or any operating system, especially Windows, has like a few files after you go through the post, okay? And after you go to the post is gonna point them to those files, and it'll prepare Windows to boot. So if you have any of these missing files, for example, one of the files we call bootloader or something like that, if it's missing, your machine is not going to boot. Okay, and usually this partition, the files, these files we're talking about is hidden. They call it system hidden files. So you're not going to see them unless if you go to I think the folder option, and you go to view, and from view you can see hidden files, and you need to uncheck the hidden file, then you can see them. And there's a reason why they hide them, because they don't want you to delete them accidentally. Okay, that's why you cannot view them, you cannot see them for that purpose. Okay. So this is very, very, very important, because sometimes what happens, if you boot your machine and it's going to tell you missing bootloader or something, that means one of those system files is missing. Okay. And usually you can repair it. You can copy it from a CD and you put them on that whatever place. But before you do that, you need to unhide them first. Okay. Okay, and not assigned a drive letter cannot be viewed in the file explorer. Yes, those are system partition or system volume. You cannot see them. Okay. So now I've seen before, like long time ago, they used to make like a small. I'm talking about like 98 XP, whatever. They used to make like a small partition just for the system volume. And usually they put the system volume and the boot volume on a different partition. And a long time ago, also, we used to have in Windows 98, we used to create a boot disk. So little diskettes with 3.5, we install it in there, and you allow Windows to boot to get you to the prompt. Okay. So they have like a few files to boot. And that's what we call the system volume. So you need to distinguish between the two. This is very important to know the difference between the boot and the system volume. And actually the name is misleading, okay? Because you think a boot volume, you will think that's, oh, this is the files that allow the machine to boot. But that's not the case. Okay. The boot volume is the Windows folder. When you access the Windows folder, because you're gonna have on the system volume some files that's basically whenever it boots up, it'll point them after that to the boot partition, to the rest of the Windows files, to the Windows directory. And of course, in a Windows directory, you have a lot of, or volume or folder, you have a lot of different subdirectory or subfolders under that Windows folder. And one of the most important subfolder in there is the System 32, if you look at it. And usually you put on that System 32, you put all your libraries of drivers, okay? So, but anyway, you can explore into that. Whenever you go to Windows directory, you can see a lot of different subfolders, and don't delete anything, but you can view them if you want to. Any question at this point? So to get to this screen right here, yeah, you need to go to disk management, and you can see whenever you install the operating system, it's going to create a couple of partitions. One of them is the recovery partitions, okay? And it is good to make like a disk for this one here for recovery. So in case your machine messed up, so you can recover it. And that's basically your C drive right here, which is 126.4 gigabits. It's healthy. So that's basically whenever you install, the operating system is going to default to C. So everything will be on the C drive. Okay. Let's see what else to talk about. Of course, you have the volume and disk types. We talked about that yesterday. We have the basic disk, which accommodates only basic volume, and that's by default. Whenever you install it, it's going to be in basic. Okay, so you're going to have a simple volume or volumes. Basically, it's just the if you have like one 500 gig hard drive, you installed Windows and you didn't do anything, basically install the whole capacity. So you're gonna have a volume for almost 500 gig. Okay. With this kind of disks, cannot hold a volume spanning multi-disk or be part of RAID. Why? Because it's basic. As long as the drive is in the basic disk, it's not, you cannot join empty spaces from that disk to another one. Yeah. And it cannot be part of a RAID. So now they call it volume. We used to call it partitions in the old days. Okay. And usually we partition the drive. Like if you have 500 gig, we make 250 or whatever, 100 gig for the operating system. And the rest of them, we can put some kind of applications or data or whatever. So it used to be a partition. Partition basically is like the hard drive. When you get it, it's like a piece of paper. Okay, it's a blank. Then after that, you partition it. Partition it basically, it makes place where you can write to it. Okay, so that page you can divide it into sections. And say, well, okay, I'm going to divide it in half. The top part of that page, I want to make it for the operating system. The bottom part of the page, I want to make it for example, applications or data or whatever. So some people that say, no, I don't want to fool with this. They make it is just like keep the one page just for the operating system, and they mix the data files with the everything is like in one volume or one partition, which is not recommended, by the way. Okay, volume on the basic disk are called partitions, like we said, and can support a maximum of 4 partitions. So basically, you can partition that disk you put, the basic disks, into 4. 3 of them is a primary partition. Primary partition, basically, you can make one of those primary partition an active partitions. And when we make it an active partitions, basically, this is where you can allow Windows to boot. That's why they call it active. Okay. So the active partition is basically where the Windows boots from. And also you can make a extended partition, which is basically out of this partition, you can divide it into too many logical drives. And that's an extended. They call it extended partition. Okay, so whenever you partitions, you have 2 ways to do it. You can choose the old one, which is MBR, which is the master boot record, most common method that has been around since DOS. That's an old type. And it used to be, it used to cause a lot of problems because viruses gets into the MBR. So if the virus gets to the MBR, well, guess what? Because in that sector, okay, that allow the operating system to boot. If this is corrupt, Windows or operating system cannot boot. So that's why and it's limited in size, support volume size up to 2 terabytes. So the new technology, that's what I call GPT, Guide Partition Table. So that's what they moved to this kind of partition since Server 2008 and Vista. Vista is the worst operating system anyway, but Windows Server, we run Windows Server 2008 for a long, long time. But anyway, so this is the two options. The difference between the two, the GPT, which is most of the new system use it now, it support larger volume size. So it goes up to 18 exabytes, which is 1,000,000 terabytes. I don't know if we're going to have a drive like that, but that's a lot of space. So now, starting with Windows Server 2016, new disks are initialized with GPT, but you can select MBR if desired. Now, why you want to go backward? Okay. Why you want to go backward? So, what's the feature of GUID partition table? Offer improved reliability through partition table replication. So we need some kind of replication and some error check. Cyclic redundancy check, CRC, protection of the partition table. Because remember, I told you earlier that we used to have a problem with MBR. So with this GPT, it has some kind of protection of the partition table. But this is whenever it's a choice you need to make, and you can do either way. But like I said, why you want to go, especially on server? I can understand if you want to play with this one on Windows 10 or Windows 7 or whatever to put MBR, whatever. But on server, you want that server to be secure and more reliable. So, and you support higher volumes, disk size. So you want GPT, okay? Then whenever you prepare your disk, we have the storage space on this drive. Basically, when you divide your drives into partitions, then it's gonna divide it into sectors. Sectors is the smallest piece of space that you can put your files in it. And sometimes they group, not sometimes, they group sectors into like a few sectors into clusters. They call it clusters. And sometimes if you go to the disk, they give you an error, bad sector or bad clusters. And sometimes we used to do fix disk to repair it. So if you have a bad cluster, you cannot put information in there. So now with the smart operating systems, okay, they can detect all these and they don't write any information on them or something. But you have an options. The traditional is 512 byte sector. But also you can have advanced format to use 4096 byte sector to support. Now, why you want to use 4096 byte? To support larger size drives, okay? And also you need to see basically to make that choice, you need to understand your file system. Like for example, when you create files, okay, how big is your files, okay? Because let's say you have a file of 8 bytes. So the 8 bytes you divide by 512. No, I'm sorry, like not 8 bytes, 800. So let's say 800 bytes. So or 8,000 bytes. So to get that, you have to write that file into too many sectors. Okay. So if you have a large file, it's better to make your sectors larger because this is increased performance. Now, at the same time, if you have 4096 byte, if your file size is less, you might lose a space. So for example, if you have like 9,000, so you're going to have one sector 4096 and the other one's another 496. That's two. And then you have few of them, so you're going to have three sectors to write that. So on the third one, you're not writing much. You write a little bit, but the rest of them are going to be free. So there's some advantage and disadvantage to do that. So allows Windows to support much larger volume size than previously possible using 512 bytes. And now they have something called Advance, which is the 512E, which is they call it the Hyper, which is advanced format disk called 512E drive. Usually you need to study your file, you need to understand your files, if it's a larger file, smaller file, mid-size files, and it doesn't make any difference which one you use unless the only difference makes is on the performance. Okay. Like for example, if you have a smaller files or larger files. If you have larger files, you go with 4096. If you have small files, you go with 512. It also depends on the size of the disk. If you have a lot of storage, bigger storage, also go with 4096. Anyway, to know which one you have, they have some kind of command you can use. The fsutil, fsinfos, sector info, and followed by the drive letters. It could be C, it could be H, it could be G, and that's basically how they give you the information right here. You run that from the command prompt. But you have to have some kind of administrative admin to run it, and otherwise it's going to give you access denied or something. Okay. Questions? Oh man, that's another thing. I didn't see that. Somebody said. No, I'm not stopping going now. I'm stopping this. You should interrupt me and tell me record, please. I guess my fault. So now they talk about volume and disk types. Like we said, simple volume means what? Reside on a single disk. Like if you have a disk, okay, you have one volume, and that is just it. It's one volume. With multiple partitions if you want to. So, but it's one disk. Usually we start with disk number 0, okay? And that disk could be basic or it could be dynamic, doesn't matter. But the main thing is in one disk. Now we have span volume, which is extend across 2 or more physical disks. So basically we can make in the 2 drives, if you have 2 hard drives or more, you can create a volume and you start writing on the first disk. Once you finish your data on the first disk, then it goes to the next one and the next one and the next one. And that's what we call span volume. With this kind of span volume, I don't know what's the advantage of it, but um, it does not have fault tolerance, because if you lose one of your disk, you lose access to your data. So it doesn't have any performance and doesn't have any impact on performance and doesn't have impact on redundancy, or fault tolerance, I should say. Fault tolerance. Okay. Now, but I think with this one here, you can the only advantage of span volume. Anybody think about one advantage at least of span volume? Let's see. Can you guys can you give me one advantage?
If you run out of room on the first drive, the file continuates onto the second drive.
Well, for example, if you have a multiple disk and you have like few free space on each one of them, like for example, on disk 0, I have like 2 gig, and the other one has like 6 gig or 3 gig, whatever. So instead of wasting all these empty space, and I can combine them and make a larger volume out of it. You see, then I can put stuff in there. Okay, but really doesn't have any performance, doesn't have any advantage on performance, and does not create any fault tolerance. Now this one, the stride volumes, it works the same thing, but extends across 2 or more dynamic disks, usually between 2 to 32. I guess you can do that. But the information is written in multiple disks at the same time. So let's say like we have like 2 or 3 disks, like we have disk 0, disk 1, disk 2. So we can write the information simultaneously on those three drives. Now, what's the advantage of this one is what? Speed. Especially if you have a database and you want to expedite the writing processor, because as we talked about, usually hard drive is a bottleneck. So it's like you guys, we write an information and each one get pencil and paper and start writing. You write on your page and somebody else is going to write, somebody's going to write. So basically you distribute the load of writing, okay? And we write on the same time. So you're going to have multiple heads. Usually refer on multiple heads because of the disk all days. They have a read heads and write heads, okay? So that increases performance, but still does not give you what? Fault tolerance. If you lose, you lose. If you lose hard drives, you lose the data. That's it. There's no way to recover. Of course, unless you have what? A backup. Now we have a mirror volume, which is RAID 1, and use space from 2 dynamic disk and provide fault tolerance. Well, this is an old method we used to use. It gives you fault tolerance, but really it caused a lot of it's slow. Why? It's like I'm writing the same information on 2 drives. It's like me, you tell me something to write, I have 2 pieces of paper. I'm going to write it on the first paper and the second one. First one, second one. And the advantage of it, if I lose paper 1, so I still have the information on page 2, on paper 2. So, and that's what we used to call it mirror. And usually mirror, this is what we call disk mirroring, and we used to connect the 2 drives into same controller. When somebody like on the old days, they said, okay, how about if the disk controller goes bad? And then they say duplexing, like mirror duplexing. Basically, we put two controllers. We can attach one disk to controller one and one disk to controller two. And if one disk or one control goes bad, they will still have the information on the other one. This is no longer, I mean, it's some people that you have use for it, especially on critical environment, because basically why we need to do this, because disk is it's a single point of failure. So if your hard drive crashed, it's crashed. So you cannot use your machine. Can you imagine if you are in business, for example, and you're doing a cash register or something, and okay, and you didn't have fault tolerance on it, and your drive is poop. So how are you going to recover it? If you have a volume rate 1, which is mirror, no problem. The first disk goes bad, okay, we can go and use this number 2. I mean, this number 1, because we all start with disk 0. So it's like a spare. Let's put it that way. It's like you have a flat tire, okay? If you don't have a spare, you cannot drive anymore, okay? But if you have spare in your car, okay, you put that spare and you go. So that's what they rate 1. And that's what they say. If one disk failed, the other has a copy of the data. Now, the advantage over here has fault tolerance, but the disadvantage is you waste one disk, and also it's slow because you want to write to the 2 drives at the same time. Now, RAID 5 volume, basically, you need 3 or more disks, first of all, to get RAID 5. So with this one here, we write, if you have 3 disks, for example, we write to the first disk, the second, the disk 0, disk 1, then we create parity on disk 2. Okay, so remember, we start from disk 0. So disk 1, disk 0, disk 1, disk 2. And then second file I'm writing, maybe I write to disk 0, I put parity on disk 1, and I write on disk 2. So it doesn't matter which drive fails, I still can operate on the second 2 disks without interruption. Okay? So we have as 3 disks, disk 0, 1, and 2. At this point, it doesn't matter what disk fails, I still can operate. Usually, we put them on the server, and you have some kind of LED. As long as the LED is green, means all your drives are working properly. The minute you see red on one of the drives, that means it's bad, okay? So you try, for example, to pull it out, clean it, put it back in. If it works, that's fine. If not, it means that disk is bad, need to be replaced. If you replace it, you get another drive and you insert it in without shutting down the machine or the server. That's what we call hot swap. It's swappable. You swap the bad drive with the new ones, and you go and continue your operation. No interruption. So with RAID 5, they'll give you performance and give you fault tolerance. Okay? Now, but they have some rules you need to follow. I mean, it's preferable to use the same kind of disks and same size. What I say, same kind, same brand, and same size. And especially on the server, I expect those to be SCSI. And when you do this kind of RAID 5 volume, Also, you need a hardware RAID because we have hardware RAID and we have software RAID. Software RAID you can configure it with Windows. Hardware RAID, you have a hardware controllers controlled. After you configure the hardware RAID, then it's gonna prompt you to install the operating system. So the RAID is already created for you. All what you need to install the operating system. So, like I said, it makes sense to make same brand name drive with the same size. Now, somebody said, "Can I make a different size? Is that going to work?" The answer is yes. Well, suppose disk 0 is 1 TB and disk 1 is 500 gig, and disk 2 is 1 TB. So the amount of space, usable space in this case. So let's talk about the total size now. Total size is going to have 2.5 TB, right? Because we have two drives as 1 TB. That's 2 TB. And one of them has half a terabyte, which is 500 gig. So we have 2.5 TB total size. Now, when you do RAID 5, the smallest disk, we're going to combine the smallest disk, which is 500, and make them as usable for information or data. We can restore information, which is, so I'm going to take 5, 5, 5, and the other one's going to be lost, okay, on the RAID. So that's why it's better, because it's always default to the smallest drive to make the RAID. So it's always good idea to do what? To put the same size. What's the advantage of RAID 5? Speed, performance, and fault tolerance. Did anybody get a chance to use this RAID 5 somewhere? I use that every day. Okay. Disk formats. Before you use the disk, you need to format it. Basically, it makes it ready. Otherwise, we cannot use it. Well, we got options. We have a lot of different filing systems, especially for Windows. We have FAT, which is File Allocation Table. And we have the NTFS. And we have the new one, which is we call it the Resilient File System. Okay, so FAT was like an old file system for Windows 95, Windows 98, and all that stuff. We start with FAT 16, even DOS. Then FAT 32, then after that, we came up with Windows NT, we start using NTFS. And that's what we call it, the New Technology Filing System. So by far, the NTFS is the best choice to format your drive, unless if you want to use storage. If you use it, you don't want to boot from that particular drives or so. It's recommended, especially in cloud and virtualization, is recommended to use the resilient file system. The resilient file system will support a higher capacity, and it's designed for storage, okay? But it's not designed to boot from it. So for boot and what else? And security and all that stuff, you use the NTFS. File compression, you use NTFS. This is for what? If you're using just for storage, you use this one here. Okay. So modern file system have some or all of the following components: file naming convention, hierarchy organization, data storage method, metadata attribute, and all that stuff. Well, the file naming convention in the old days when you used to use DOS, I think you limited on the file name to 7 characters. And then after the file name, you say file one dot, then you have the dot, which is the file extension, which is a 3 character. So for example, file one dot exe, file two dot whatever, bat. So that's basically how we used to recognize or name the files. Now with Windows, so if you use a file fat and you say, okay, I want to name my file payroll 2016. Whoa, that's a lot of characters in there. Exceed the 7. So what's happening is it's going to take the first 7 character and truncate, ignore the rest. Okay, so that's why we don't use fat anymore too. So, but anyway, it doesn't matter. What filing system basically you're gonna work with the NTFS. They have some kind of filing convention you need to follow, and I think it's support up to I forgot. It's like 155 or something characters. I forgot how many characters they support. But usually you give a meaningful name for the file. And they talk about hierarchical organization because the file system it's like upside down tree. Okay, so to get to that file, you have to go to the root. Okay, the root is first. That's why they call it upside down tree. So, for example, you have to go C colon slash folder one. Then you can say slash folder one, whatever name is the subfolder, till you get to the file you want to access. And this is what we call the path. The path is designed in hierarchical structure, organized in hierarchical structure. It's like upside down tree. You start with the root first till you get to the branch, okay, or to the leaf actually, not the branch, because you have the root, and the root you have the what, the branches, and in the branch you have sub branch. So the branch is like a folder. Sub branch is a subfolder, and inside the subfolder you might have another subfolder to get to the leaf. The leaf is basically the what? The file. Okay, so you cannot sub it anymore. You cannot have sub files. You can have subfolders. So that's what you stored it. And of course, you have on the file system, you have a different characteristic. One of them they call the metadata, and which is basically a description of the file, not description of the file. For example, like when the file is created, who can access it, and or last times access it, and this kind of information in it. When that, yeah, they give you the date, for example, when the file is created, when the last time it's been accessed. Did you change anything in a file since the first time or last time? So, and that's basically what metadata. Now, the attributes basically you can hide the file if you don't want anybody to see it. You can hide it, and you can do whatever you want to do with it. And of course, you can have an access list. You can control who can access it, who's not. And also, they have, for example, read, write, what you can do with it if you can access it. Because as we can talk about the access list, access control list, because it's basically like a permission. So if you have permission to that file, what you can do with it. Some people can read, some people they have a right to it, modify, and so on. Okay. This is another topic we have to talk about. Okay, some questions. Let's see. Okay, it's the fat file system. Here, the rule of thumb, okay, some people said, okay, when I can use fat, okay, usually fat is designed for a smaller partition. You have a small partition, you can use fat like a jump drive or something like that. You use fat. So fat file allocation consists of two variations, fat 16 and fat 32. And that's why we call, like when we used to have DOS operating system, we use fat. And they say limit to 2 gigabyte byte partition. Well, it's true and it's not true. We used to have a problem with it. It depends on the operating system too. Now, FAT32 allow partition up to 2 terabyte in size, but Windows 2000 and later limit size FAT32 partition at creation of 232 gig due to performance. So, if you design a server today and you have a choice, what file system are you going to use? We're not going to use FAT. But if you have a smaller, first of all, if you have an older operating system you're using, like Windows 98, 95, whatever, and you have a small drives, then you can use FAT. Okay. So, and the reason why, because as they can say, some people they use FAT or prefer FAT because NTFS is more secure. When anything it has more security on it, basically what? It means it has more overhead. FAT has no security. And also the only security that you have on FAT, if you have a folder on your server and you have some permission on the folder, then the clients, if they don't have permission to it, they cannot access it. But that security does not propagate to the file level. So I cannot put security on file levels in FAT. And NTFS, I can put security on the file level. And that's basically the main difference. It's like I said, if you have a small partition like flash drive or any of these media, like a small, like imagine they have like 1.44 disk, like the 3.5 disk, the old one, floppy disk. You don't have choice but to format it with FAT. Okay. NTFS first introduced, like we talked about, Windows NT, support files, and that's the key, support files and folder permission. Well, let's put it that way. That's now NTFS is the file of choice in the Windows operating system. Unless if you're going to go back in time, but we always go forward, we don't go backward. And that was introduced in support file and folder permission and advantage over FAT. Features added with release of Windows 2000. So Windows NT start first, which is in the 90s, mid 90s, I should say. We start 3.5, Windows NT 3.5. This was when we started. Then they come up with Windows NT 4, and they came up with two versions of Windows NT. One for client, which is like workstation, and one for Windows Server. So after that, it lasts for a long time. I'm talking about from the 95 up to mid 90s, early 90s to 2000. Yeah, it's almost 5-6 years. Then in Windows 2000, they modify it, so they add to it. So what they add this quota, so we can assign space for users. We can do this quotas. We can do volume mount points. We can do shadow copies, this is very good for recovery, shadow copies. We can do file compression. And the most important one, encrypting file system, EFS. So now I can create a folder and encrypt that folder, and any file I put in that folder automatically will be encrypted. So this is a lot of advantage to use NTFS. Now, NTFS and resilient file system. So, like I said, the resilient file system does not support file compressions, disk quotas, and EFS. And you cannot boot from RAFS volume. So I have a couple of students on one of the lab a couple of semesters ago, and they doing, for example, they did what they call virtual machines, and they put them on, they format it as RFS, Resilient File System, and they cannot boot it from it. I said, okay, you read the instruction. Windows cannot be booted from this one here. Well, somebody said, okay, if it does not support this quotas, does not support compression, what the heck, why do we need it? And the reason, like I said, we need it for storage because it support volume up to byte. And we talked about the exabyte a while ago, like 1 million terabyte. This is like double or triple, okay? So, well, somebody said, why we need all this kind of space? Why we need all this storage for? Well, remember what we talked about yesterday? Big data. We use the big data. Did we talk about big data yesterday? Or not? Not for this class.
No, we talked about it.
Yep. So we need it for big data. So the disk format of choice for storing virtual hard disk for use in storage space on Hyper-V server, and is not meant to be replacement to NTFS. So is only for storage. And for to boot, to use for operating system, we use NTFS. Still, this is the file of choice. Okay, hot add, also known as hot swap, being able to add a new hard drive to a server while it's powered on. What do we need for that? We need the operating system need to support it, and also the hardware needs to support it. So as long as the server hardware is supported, that's what we're talking about. Like, for example, on the servers, we used to use the SCSI drive. We replace those drives, and you can replace it. Now, some machines now is not only you can replace the hard drive or add another hard drive while the server is running, also you can add memory. It's amazing while the server is running. So, by default, a new disk must be initialized and brought online. Afterward, you can create a volume and format it. That's why I recommend whenever you create, for example, what do you call it? Virtual machines. You remember we have like two, generation one and generation two. If you do generation one, you're not gonna be able to do hot swap or access any of your drives or settings while it's running. You have to shut it down, and then you go to setting and you can adjust whatever you want. But if you're using generation 2, you can do all that stuff. So by default, new disk must be initialized and brought online. Yes, you can add a disk, and you're not gonna see it when you go to disk management. So what you need to do first, you need to initialize it first, and it'll say online. After it's been online, you can do whatever you want to do with it. In disk management, you can convert the disk to dynamic or between MBR and GPT partition scheme. Now, somebody said, okay, why I need to convert to dynamic? Well, if you want to use span volume, stride volume, if you want to do RAID, then you need to change from basic to dynamic. Okay. Otherwise, you cannot do any of this. Question about this one. Okay, there's a lot of stuff you can do also with configuration. And beside GUI, you can use the PowerShell. And I think was one of the question on your test. Get disk. Remember that on your server test? That's one of the, for example, to bring disk 1 online and initialize it, you put set space disk space number 1 space dash is offline false. Initialize disk. So you remember when we talked about how a PowerShell use a verb, noun, parameter, value. Okay, so parameters and value. So you can run multiple parameters. Okay, so it's very good to start understanding how PowerShell operates. Now, after you bring it online, then you need to what? Initialize the disk, initialize disk number 1. Now, how are you going to create a partition? New partition, disk number 1, then you set the size to 10 gig, and you can give it drive back. You can do the same thing on have another partition in command prompt. Anybody remember it? We used to partition it to make the flash drive bootable. Disk part. That's what we used to do. Disk part. So anyway, this slide here is basically talks about the using PowerShell, how to use PowerShell. So if I were you, I can I don't know. Do you have on your lab something like this? If not, I'm not expecting you to mess up your machines to do that, unless if you have a partition. You partition one of your partition on your drive, and you can fool with this stuff. Yeah. But even they can put what file system you want to use here. Say a new file system label. You put resilient file system volume. So this is just a practice. I'm sure you have one lab to do all that stuff. So please take your time, especially when it gets to PowerShell labs, to understand what you're doing, because it's very, very, very important. Any question at this time?
Yeah, Mr. Charif.
Yep.
Okay, I was noticing in the previous slide, if you go up one slide to the preparing a new disk for use.
Yeah.
we had a question. We had a question on the test about what is it called when you can basically add something while the server's still on. They had both hot add and hot swap. If you selected hot swap on the test, it was marked wrong.
Oh, yeah. That's common. I'll go over it.
Okay.
The reason why, because sometimes if you misspell it, or if you don't put, like for example, they want them to answer in like one way. But oh, yeah, I understand what you mean. Yeah, that's a problem sometimes. I'm glad you told me. Anybody else has this problem? Like for example, if you put on the answer support instead supports, they're gonna mark it wrong because you didn't put the S. Because on the answer sheet, you compare what you put to the whatever a possible answer. If it doesn't match, they're gonna mark it wrong. So this is one of the common issues with the testing like this. But we'll fix it. So I'm glad. I mean, if you have this kind of problem, always go through your test, and if you think you answered it correctly and they mark it wrong, Jill, let me know so I can give you points. I go back to the test. You remember what question was that?
I think it was like in the 20s or something, late 20s, early 30s, out of the 53 questions.
I'll go over it and see.
Okay.
Oh, no problem. Okay, let's stop right here and prepare for the next class. If you don't have a question, we can end it here. And your next class is going to be 9:25. I'll send you an invite. But please do your lab. I've seen some people that don't do the lab yet. So what you waiting for? Next semester? You want to do the lab next semester?
No, I'll have them all done this weekend.
Anybody has his own lab, like a Windows server? I bought one actually a couple of weeks ago. I bought what do you call that? Dell workstation with 48 gig of RAM for like I think it's like but less than $300.
Can you send me the link?
Oh, go to eBay. Go to eBay. They have all kind of machines, and the good machines to do that is Dell Precision. Dell Precision Workstation. Okay. It's classified as a workstation, and they have different models. Actually, I bought one for my friend. I think it's cost me with the shipment $300. I'm supposed to receive it in here. So always look for one. If you have hard drives or you don't at home?
I have some. I have externals.
Okay, so
USB external.
They give you an options. They can give you like 150 gig SSD and 1 terabyte regular. So it's always good too. The most important part here is the storage and the memory. And the reason why I select this model because they have a Xeon processor, so they can run 24/7. So anyway, I can send you some link to some of them. I'll recommend a few of them. Okay.
I'll shoot you an email on that.
All righty. I'll see you in a few minutes.
Sounds good. Thank you.
No problem.